Here we'll cover distribute lists. So distribute lists are used to filter routing updates. In order to filter those routing updates, they call an access control list. A lot of times an ACL is used to define interesting traffic or to filter like user traffic. In this case, we're going to use our ACL to filter routing updates. So in order to configure a distribute list, we have to create an ACL to permit or deny certain networks. And then we'll create a distribute list that calls that ACL. It links that ACL or calls it out and uses it. Now our distribute list command will be different if we want to filter routes coming in or routes going out. So if we want to filter routes coming in, we'll do a distribute list, either an ACL number or name, and then the keyword in, and then an interface type and interface number. If we're going to filter things going out, then we'll use the distribute list, ACL number or name, the keyword out, and then we can use interface type and number, or we can also use a routing protocol or a routing process. And then depending on the routing process, obviously, we would either use the autonomous system number to specify that one, or the process ID. With the IGRP, we'd use an AS number. With OSPF, we'd use a process ID. And the big thing to remember, aside from the other notes that I'll give you as we go through it, is don't forget the implicit deny all. So if I'm going to permit some statements, remember, if I permit a couple statements, at the end of that, there's going to be a deny. So pay attention very carefully, especially in larger networks. What we're doing right here is a very simplistic network, very small network. It's there just for an example. It's very important to look at the effects of what you're doing and really think through the process. So let's go ahead and configure. So here's the protocol, or wow, here's the network we're working with. Between these two links, so between R1 and R2, I'm using the 192 to 168. I just kind of want to help you understand how I've written this out. I'm using the 192.168.1.0/24 network with gig 01 on R1 being 192.168.1.1, and then gig 01 on R2 being .2, and so on. So we do 192.168.2.0 network with this guy being 2.1, 2.2, 3, so 3.1, 3.2, and so on. And then in order to give us some networks to filter without having to set up a whole lot of routers and things like that, I created loopback addresses. You'll find I use those a lot just because they give us networks and routes that we can use and manipulate and do things with without having to have more devices. So a loopback is just a virtual interface. Here I've created a loopback 0 on the 10.1.5 network. I see that I changed my numbering here, but that's okay. So 10.50 with a /24. So this guy here is going to be 10.1.5.1/24. See, and then you notice up here I just changed the way I did it. It's no big deal. Loopback 0 and loopback 1, I did a 10.1.1/24. So that would put this interface here in the 10.1.1.0 network. So they are each different because we're using that 24-bit subnet mask. We do the 10.1.2 and 10.1.3 and 10.1.4. And what we're going to do is we're going to allow these guys to come through. Okay, so for whatever reason, I don't want this R1 here and whatever's back here. Okay, remember we have a small network. Generally we might do this because there's other stuff within this cloud, whatever this is, right behind this guy. For whatever reason, we don't want him to, we only want him to learn about these networks. We don't need him to learn about this one or this one. So we're going to configure a distribute list on R2 as it comes through, as these networks come through, to filter it out for R1. Okay? And then when we're done with that, let's get rid of our ink. When we're done with that, and so the reason why I am going to do it here is because it'll be conducive to the next part of our demonstration, which will be when we are done, we are going to really get into, so the purpose of us, at least for our discussion, why we're looking at distribute lists, is how to handle route redistribution and making sure that it's clean and it's fine-tuned. And so then, once I do the overall, everybody's EIGRP at first, okay? So right now, everyone's EIGRP. All the routers are running EIGRP. I have them configured for IP addresses. They're all routing. I can ping from 10.1.5 all the way through to all of these other networks. once we do our distribute list first, the original distribute list that works with the whole EIGRP autonomous system, then we're going to go ahead and break this up, and we're going to put this guy here in the OSPF domain. So he's going to be running OSPF. Right? We're going to leave these guys here running EIGRP. I'm going to just get out my pen, might be a little easier. We're going to leave these guys here. They're going to keep running EIGRP. And then we're going to redistribute EIGRP into OSPF, and we're going to create our distribution list there. So that's what we create. We're going to create it here twice. No reason, just to see different ways of doing it. I'm also going to do a numbered standard ACL, and I'm also going to do a named standard ACL, and it's just different ways of doing it. So that you know you have options. Seeing different things multiple times I think is important. So that's how we'll go through the rest of this video. Before I switch to our routers, I'm going to go ahead and clean off the ink here. All right, so the first thing we want to do on R1 is just to make sure that we actually have all our routes. Doesn't do any good for me to say, oh, we're going to filter some routes out if the routes never existed in the first place. So show IP route. All right, 10.1.1 and 10.2 learn through EIGRP, and they're both on R3, so router 3. And then also through EIGRP, we learned 10.1.3 in the 10.1.4 network. That's on router 4. 10.1.5 is directly connected to us. Oh. And then we have 192.168.2.0 going between router 2 and router 3, and 192.168.3.0 going between router 2 and router 4. So our routes are all there. We should be able to ping just fine. So we'll ping 10.1.1.1, source 10.1.5.1. Whoops. Wow, that's pretty bad. 1.5 dot. And we made it there. So we pinged the loopback on R3 from our loopback here on R1. So we have connectivity. We're good to go. We're ready to configure distribute list. So let's go into R2. That's where we're going to configure our distribute list. And the first thing I'm going to do is a numbered access control list. I'll do a named ACL when we do the redistribution portion. And really, named ACLs have a little more flexibility as far as taking statements in and out. But outside of that, the distribute list really doesn't care. So we said we wanted to allow 10.1.3 and 10.1.1, right? So access list 1, or spell it right. .1.1.0 and our wildcard mask. We'll have to specify it here because this is classless. Oh, I got it for forget permit or deny. We're going to permit these guys because some of you might be seeing what I have going on, but I actually want to show you something here. So we're going to go ahead and permit because we want to allow just those networks off those loopback networks off of R3 and R4 going out to R1. So we're sitting on R2. We're going to forward or allow the 10.1.1 and the 10.1.3 networks. We don't want to allow the 10.1.2 or the 10.1.4 networks. And I'm just going to hit an up arrow here and change this to a 3. Okay. And then let's do a show run. I want you to see it. So let me show run. Include access. So we get everything, we include the access. So here's what our access list looks like right now. We're permitting these two. Now we want to call our access list in our distribute list. And if we go back to our slide, what we want to do is I'm going to take these networks and they're going to come in to R2. And before R2 forwards them out to R1, because R2 will get all of the networks, right? He's getting them all because we aren't doing any filtering back here. Right? We're not doing any of the filtering back here. So as all of these networks come in, we're going to say, okay, we want you to permit this network and this network going out towards R1. R1 should only need to know about the 10.1.1 and the 10.1.3. Those are the only networks, for whatever reason, in our planning and our scheming that R1 needs to know about. So that's what we're going to configure on R2. So let's go back to our router console. Now we're going to go ahead and go into our routing process and call our ACL that we created in our distribute list and tell it, hey, outgoing, we're going to permit these. Remember, there's an implicit deny all at the end. So if we do a config T, router EIGRP1, that's our process that I've already configured. Distribute list. I'm going to call our access list here, right, and out. And then end. And let's go back to R1 and see what R1 ends up with. First thing we want to do is we want to just wait a second and let it, do all its updates. See, we've got to do a resync, route configuration change. We want to let this happen, this neighbor change, and then we'll go ahead and we'll look over here, and we'll do a show IP route. And sure enough, we're only permitting the 10.1 and the 10.3. The 10.1.2 and the 10.1.4 aren't being allowed. So let's go ahead and ping 10.1.1.1 because according to this, we can get to it via there. Okay. And it doesn't work. And it wasn't supposed to. It was a short demonstration. Yes, we did distribute list, but what I wanted to get through is you have to think about your design. So when you're doing redistribution even, we talk about thinking about our redistribution. When we're trying to tune redistribution and routing updates, we have to think through it. And what did we do? Right. We didn't allow any of those other 192 networks. So sure, I can get to my directly connected router, but I know nothing about how to actually get to 10.1.1.0 because I have my implicit deny all at the end. So then let's go ahead and go back. What seems really easy, honestly, is to just, all we really wanted to do, if we look back at our configuration, is our topology, when we talked about it, all we really wanted to do is say, hey, you know what? This guy here and this guy here, R1 does not need to know about. So let's not propagate it through here. So how about if we just do a deny of 10.1.2 and a deny of 10.1.4 and then permit everything else? Okay, we could do it that way, or we could go ahead and then we have to permit these other networks. Even though this is directly connected, we're still filtering a portion, so we need to go through and then just permit them. But I think instead what's a lot easier in this case is to go ahead and say, you know what, I'm going to deny this guy, I'm going to deny this guy, and we're going to permit everything else because that's what we want to do on our network. So let's go back to that. So we're back in R2. Let's just go ahead, let's get rid of our access list. So our distribute list is going to be fine, and if we use the same number, we can leave that alone. So let's do a no access list 1. Now that should delete it. So if we do a do show run include access, should come up with nothing, and thank goodness it does. So now let's go ahead and do access list 1. Sorry. What do we say we were going to deny? 10.1.2.0 and the wildcard. We'll hit the up arrow, we'll deny 10.1.4.0, which would then permit everything else. Well, not yet. Actually, technically, right at this moment, we're denying all traffic or all routes to be learned or that could be learned by R1. So as forwarding out R2, we're not forwarding any routes right now because we have a deny, deny, deny. I'm sorry, we have a deny, deny, and then an implicit deny all. So now what we want to do is access list. Actually, you know what? Since it updated, let's go ahead and go over here. And you can see exactly what I said. We're denying everything. So the only thing we have is our connected routes. Now let's go back again. Doing a lot of back and forth. Hope you're following me. And access list 1, permit any. So now we'll go ahead and we'll permit everything except for these two guys. And we'll wait a second. We'll wait for everything to update. And now while we're waiting, a couple important things is I used to distribute list out. That works fine with EIGRP. It doesn't work correctly, or it doesn't work at all actually in OSPF. Because within an OSPF area, if I do redistribution, that's fine. But within an OSPF area, OSPF has to, I can't filter those LSAs because it has to maintain a synchronized link state database. So with just the way I did it without redistribution, it won't work to do distribute list out with OSPF because you can't filter those LSAs within the same area. When you do a distribute list in with OSPF, the routes will still go in the database. OSPF doesn't filter them out of the database, but they won't be in the routing tables. So just OSPF behaves just a little bit differently than EIGRP. When we do our configuration for redistribution, it'll be fine because then we can use it with redistribution on an ASBR or autonomous system boundary router. So that's fine. Now let's go back. Now that we've done our updates, and we do a show IP route, and we see that in fact 10.1.2 and 10.1.4 aren't there. And we should then also, we see the networks that we needed in order to get to 10.1.1. So we should still then now ping, and we can, the loopback in R2, which is what we wanted to do. What we didn't want to be able to do is this. And you know, I always hate doing live demos because you never just know what you missed. But this should not work. Whew, and it doesn't. So there you go. And it's not supposed to, right? We stripped it out of our routing updates. The routing table doesn't know anything about it now on R1, and we can't get there. So let's go ahead and let's transition to doing two different routing protocols, EIGRP and OSPF, and then redistributing between the two and using our distribute list again. No big deal except for that to show that we can do it, right? All right, in an effort to not take too much of your time with me just updating things, I went back through and I configured this section here with OSPF. So everything's in OSPF area 0 here. So now on router 1, we're running both OSPF and EIGRP. He runs EIGRP that direction, and he runs OSPF this direction. Before we do our distribute list, just because I think it's a good review, let's go ahead and actually do the commands to redistribute EIGRP into OSPF. Because we'll keep our access list and we'll just keep with our distribute list commands too. So we're going to go ahead and take this EIGRP, take all these routes, and redistribute them into OSPF. Now because we have classless addressing, we're also going to have to include subnets. Right. So in R2, let's do a show run, include OSPF, just make sure we're good. We do have the process running. We said we're going to redistribute EIGRP into OSPF. So we do config T, router OSPF 1, redistribute, EIGRP, oh, 1, got to have the autonomous system number. So redistribute EIGRP 1 metric. If we don't provide a seed metric, it will automatically default to 20 because I'm redistributing into OSPF, and OSPF's default cost for this particular protocol is 20. Let's go ahead and just make it 10 since we have a small network. We provide a seed metric of 10, and we hit enter. Now let's do a do show run and include. So right now, wait, let me stop. Sorry, let me pull back a little bit. We're redistributing EIGRP into OSPF. So if we go into our OSPF domain and do a show IP route, we see our OSPF external routes. So those are all of our, these here are all of our EIGRP routes being redistributed into OSPF. Remember, by default, they come in as type E2 routes, and here's the seed metric that we provided them. Okay, so routing should be happening perfectly, wonderfully. Now let's go back and we're going to look at our access list. I didn't take our access list off. I did take our our distribute list off. I didn't take our access list off. So if we do a do show run, include access, it should come up with our access list. We still are looking to do the same thing, but now we're just doing it a little bit differently. Oh wait, I forgot I wanted to do a named access list this time. Let me go ahead and delete this and we'll go ahead and do a named access list. That means I also gotta, okay, so now let's go ahead and do a named access list. I'm sorry, I forgot that I want to do it two different ways so that you could see it both times. No special reason my distribute list could care less if I call a number or a name. Named access lists are a little more flexible. So if we do IP access list, it's standard, and give it a name. We'll call it filter test. And then what did we do? We decided we denied 10.1.2.0. So this is just another way of writing. So we write a named access list instead. 1.4.0. And then we permit any. All right, so now our access list is written. This time, instead of calling a number, I'm going to call this name filter text. And now, because let me get rid of all this ink. I get going with this pen. Now this time here, because I'm running OSPF and EIGRP, and what I said was I'm going to take, this is all EIGRP, right? Wow, that was not right at all. Let's get rid of that too. Let's just, let's try this again. I'm going to grab my pen. I might do it just a tad better with that. So here we run EIGRP and OSPF. Here we're running EIGRP. Over here we're running OSPF. And we redistributed this EIGRP information into our OSPF protocol. So this time when we do our distribute list, we want to put it under OSPF here. So OSPF, first process, here's where we're going to put our distribute list. Under OSPF here, because as the EIGRP routes are learned and they're being redistributed over here, the ones we don't want OSPF to learn is 10.1.2 and 10.1.4. So we'll go ahead and do that. So router OSPF1, that's our OSPF process. Distribute, let's do tab completion distribute list, let's move this. Now we're going to call the name instead. Here, hit a question mark. We can call standard extended, the name of it, a gateway, a prefix, a route map. In our case, we did a standard, and we did a named access list. So we're going to go ahead and call our name, which is filter test. Did I do a dash test? Wait. No, underscore. Okay. Let's go ahead and do a question mark. Honestly, we can just do out right here, space and out, but let's just space. We'll do out, so you can do in or out. Notice with out, we have some options. I said that in the beginning when we looked at the PowerPoint, some of the options we had with out, just verifying, right? Just showing you some things. We have our gigabit, our different protocols, such. All we want to do is take our access list here and call it in our distribute list so that we filter those networks and hit enter. Let's, oh shoot, I shouldn't have done that. I said shoot. Show run. Where do I want to begin? I want to begin with, I'm going to begin this time, and I'm going to begin with OSPF. Okay. So that we can go ahead and we can see router OSPF, we did our redistribution, and we did our distribute list, because in our redistribution, that's part of tuning redistribution. You don't necessarily want all the networks, so you need to go, especially if you're doing two-way, multi-directional or both-way, two spots both-way redistribution. You really want to be careful of what you're allowing in and out, because you're going to end up with routing loops, almost certainly, if you just do it generically, no big deal, right? So we did our redistribute, then we did our distribute list to filter out the networks we didn't want to come through. Our access list called filter text that we filtered up here denies just these two networks. So if we go over to R1 and finish up, do a show IP. I should have set up arrow, but now I'm into it. Luckily, in fact, notice up here we did see 10.1.2, whoops, sorry, 10.1.2 and 10.1.4, and now we don't. We have filtered that routing update. We filtered those networks from the routing update, which is the purpose of distribute lists. So that is it. I think we covered everything. I hope that helped you guys.